Hey, hello, this is Brandon Clayton, the Algebra Guy. Today, I would like to talk to you about dividing fractions step by step. We're going to go one step at a time when we do this. So here's an example of what you're going to see. 7p divided by 12, or 7p twelfths divided by 21p eighths, or you can say 7p divided by 12, no matter what. But how do you deal with this? And so here are the steps right here, and we're going to go over that. If that looks complicated, don't worry, in a few minutes you'll completely get it. So let's jump to it. First, we're going to start with our questions as we normally do. How can division of fractions be modeled? What is a reciprocal? What is the rule for dividing fractions, and how do I divide fractions? Let's jump to it. So suppose we want to find a quotient of 1/2 divided by 12. Quotient means the answer for a division problem, right? We will need to figure out how many 1/6s there are in a half. That's in essence what this is saying. 1/2 divided by 1/6. So how many 1/6s will fit into 1/2? So how do we figure it out if we wanted to model it? Well, here's what we could do. We could take one, this is a whole one in blue, and here's a half, as you can see right here. And what if I wanted to divide that half, this piece right here, into sixes, 1/6? How many 1/6 would fit in that 1/2? In order to do that, you can look at it from a rectangular model and realize pretty quickly that 3, too much. All right, so, but that 3/6 would fit into 1/2. So let me circle that. 3/6 would fit in. So when I answer that question, I can simply say the answer must be 3. Because we want to, how many of these will fit in there? And now we can say, oh, there's 3 of those. 1, 2, 3. That would fit in 1/2. So 1/2 divided by 1/6 equals 3. So this is what's going on mentally, at least if you would think about it, when you're dividing fractions. Let's model 1/4 divided by 1/8. What would that look like if I modeled this? So I'm going to take 1/4 and divide it into eighths. How many eighths will go into 1/4? So let's take 1/4. Let's start off with that. Here's all my 1/4 to make a whole. What if I want to divide one of these into 1/8? How many would it take? Well, let's pull that up. And we can quickly see again that one of these 1/4 takes 2 1/8. So this answer will be 2. It takes 2 of these things to go into 1/4. And as you can see, no matter which 1/4 you choose, it's all going to be 2 of those 1/8. What about 2 divided by 1/4? How would you model that? Well, instead of that little 1 up top, we're going to put 2 of those pieces. And how many 1/4 would it take to make up this 2? Well, if I drew it all out, it would take 1, 2, 3, 4, 5, 6, 7, 8 1/4 to make up that 2. So the answer for this one, just by looking at the model, would be 8. Because 4/4 make up this one, 4/4 make up this one, and that takes 8/4 to make up all 2 of those pieces. Now, we just did a problem that said 2 divided by 1/4. But I want to make sure it drives home as we think about money. It's amazing how much better your mind thinks when we put dollar signs and cents at the end of a number. So let's use money to model 2 divided by 1/4. We can think of we can think of it as this. How many quarters, because we have 1/4 is 0.25, is taking $1 and dividing it into 4s gives you 4 of these quarters, right? So we're saying how many quarters are there in 2 whole dollars? And that's how you could think of it. And of course, we'll think there's 8 quarters in $1. And I'm sorry, in $2. So when you think of it in money terms, it becomes simple. So if I said 3 divided by 1/4, you can say, hold on, that's just quarters. How many quarters are in $3? So that's 4, that's 12 quarters. And people will be amazed, how are you doing that so quickly? Well, because you understand how it's working and not simply employing mathematical processes. All right, so using fraction tiles, we showed that 1/2 divided by 1/6 is 3. Notice that 1/2 times 6/1 also equals 3. How can that be? So notice the similarities, right? They both have 1/2. Both have 1/2. However, division is here, multiplication is here, And 1/6 is here, 6/1 is here. So what could be the difference here? How are 6/1 and 1/6 related? Well, I don't know if you've heard this word before, but they're reciprocals. Reciprocals is anytime you have a fraction, let's say 3/2, and if you wanted the reciprocal, you would simply swap the numerator with the denominator, making this 2/3. Or if I had a number 5/9 and I said, what's the reciprocal of that number? You would easily give me 9/5. Pretty simple, right? If it were -1/3, you'll take the reciprocal to be -3, or -3/1, which is the same thing as -3. So just understand a reciprocal is when you flip it or exchange the numerator for the denominator, whichever you remember. I'd rather you remember the one that has a mathematical language, because that's how you'll often hear about it. So they're reciprocals. Why is that important? Because in understanding the division rule, we actually need to use a reciprocal. So let's look at this. Anytime you have A over B divided by C over D, so any two things divided, how are we going to handle that? We're going to keep the first one just the same as it is. And then we're going to change the division sign into multiplication sign. And the second thing we're going to do is reciprocate this last fraction. And please be sure to do it in that order. You can't say, I'm going to flip the first one and then multiply. No, you have to keep the first one, change the division to multiplication, and then do the reciprocal of the last fraction. So let's do some practice problems to drive that point home nice and well. So what about this? So I remember I need to, did I give us nope. Okay, the steps. So I just said it, right? So let me make sure I demonstrate it. Keep this first one. So I want to divide and write in a simpler form. So I'm going to keep this first one. This is the same thing as saying 2/5. And instead of division, when I divide, I need to do what? Change it to a multiplication. Now we have -3/7. Well, to divide, I need to make sure this last one, we take the reciprocal. So this is now going to be -7/3. All right, at this point, we need to remember our multiplication rules, which tell us simply to multiply straight across. And I know this is going to be a negative fraction, so I'm going to get that part out of the way before I forget, because I see this negative. 2 times 7 is 14. And 5 times 3 is 15. And they said they wanted it in simplified form, so let's look and make sure there's nothing else we can take out. Well, 14 has a 7 times 2, and that's about it, 14 times 1. 15 has a 5 and 3, so they don't have any common factors in common. No greatest common factors or nothing other than 1. So this is our simplified fraction after dividing those two fractions. Let's try another one. I encourage you to try this one yourself. What are you going to get as your answer if you divide -3/4 divided by -7/8? Pause it here and try to work that, please. All right, I'm hoping that you identified that we're negative divided by another negative. And when we divide, the same sign is going to be a positive. So I'm going to rewrite this just so I don't get confused and forget about that without the signs, because negative divided by negative gives me a positive answer. Now I remember my rules that say when we divide, we keep this first fraction. Instead of division, we what? Multiply, and then we take the what? Reciprocal. So that's going to be 8/7 now. And let's change the color a little bit. So now we got 3 times 8. 3. Instead of 8, I want to make sure this is simplified. So I'm going to write out the primes for 8. And that's 2. Oh, no. That's 2 times 2 times 2. Because 2 times 2 is 4. 4 times 2 is 8. So this is the same thing as 8. And down here, I'm going to write out the primes 2 times 2 for that 4. And 7 is already good as it is. So can I cancel anything on top and bottom? Absolutely. Those 2's can go. These 2's can go. And I'm left with, I think that's it. So 3 times 2 up top was just 6. and just a 7 below. So when I simplify it, I now have 6 over 7. Now, if I didn't draw out those prime numbers, I would have gotten 3 times 8, which is 24, because you go straight across, right? And 4 times 7, which is 28. And it's no problem doing it this way. You could have taken these numbers and found the greatest common factor and divided out those factors and got 6 over 7 too. Because it looks like 4, right, divides both of these. 4 on top, 4 on the bottom would get you right back to here. That's why we were able to take out 2 times 2, because it's the same thing as our 4. So there's not just one way. I don't want you to get stuck thinking that way. Let's try another one. Again, I want you to try this one before I work it. All right, so I know that I'm going to keep my first fraction since I'm dividing. I'm going to keep that first fraction 7 over 18. But I'm going to multiply the reciprocal. Instead of dividing, I'm going to multiply, put 27 over 14. All right, since I want to simplify the answer, I'm not going to do 7 times 27. That's going to be a big number, 18 times 14. I'm really just going to simplify, start breaking this down into smaller numbers. Now, I'll be honest with you. That's not the way I do it, because I started to realize that this 7 and 14 have something in common. So they can both divide by 7. So before I even start setting this up for those who can see it, we could just say, well, this 7 divided by 7 gives me a 1. And 14 divided by 7 gives me a 2. So we can go ahead and take out that 7 right now from the top and bottom, leaving us with just a 1 and 2. And I can look at 27 and 18 and do the same thing and say, well, this 27 and 18 have at least a 3, because 3 times 9 is 27, and 3 times 6 is 18. So 27 divided by 3, let's get a different color. 27 divided by 3 gives me a 9. Divide that by 3. Divide this by 3. That's a 6. So now I end up with 1 times 9, which is 9. 9. And 6 times 2, which is 12. See, I'm already starting with much smaller numbers. But obviously, I still got some work to do, because this is not as simple as it can get. I can break this down even further, because 3 times 3 gives me 9, and 2 times 2 times 3 gives me 12. And I can see that my 3's are able to cancel, leaving me with 3 over 2 times 2, which is 4. 3/4. So that's one way you could have done it, but I'm going to go ahead and do it the way I've been talking about for those who don't like that way or just want to see it the way I've been teaching it. So I'm going to go back to this point, and I'm going to say 7, and for 27 I'm going to say this is 9 times 3. So 9 can be written 3 times 3, and then times another 3. And on the bottom I have 18, so that can be written 3 times, what is that, 6, so 3 times 2 is 6, plus times another 3 is 18, so that's the 18 part. And for 14 it's going to be 7 times 2. So those are all my prime numbers, and I can start canceling, right? So 3 and 3 goes away, this 3 and 3 goes away, this 7 and 7 goes away, and I'm again left with 3 on top and 2 times 2, which is 4. Look at that, voila. No matter how you do it, that's what I love about math, is you don't have to take just one way. Just keep working it with the way that feels comfortable to you. Sometimes it may take longer that one way, but as long as you're understanding the math is what's most important, and you'll pick up faster methods. Closing up, how can division of fractions be modeled? We answered that with those rectangles, and talking about how we are dividing that 1/2 into so many fourths as it is. What's the reciprocal? Reciprocal is simply when we flip or take the reciprocal or flip the numerator with the denominator. This is not equal. I'm saying this is going to here. What's the rule for dividing fractions? Well, you keep the first one. So 3/4 divided by 4. You keep the first one, 3/4. Multiply the reciprocal. So 4 is the same thing as 4 over 1. So we're going to reciprocate that to 1 over 4. and then you multiply straight across like you do with multiplication. How do I divide fractions? That's the same question, so that's how you would divide them. Thank you guys for tuning in. My name is Brandon Clayton, the Algebra Guy, and I will see you next lesson.